Hello everyone and welcome you all in this next class where we are going to discuss a new topic. Since now we have discussed an introduction to limit state method and then we have discussed the design values and characteristic values. After this, I would like to discuss something, a fine line differences between the two methods of design philosophy, that is working stress method and limit state method. So the topic is like comparison between WSM and LSM. So if we look at the basic design criteria in WSM, we will see that it is based on elastic theory. Now, elastic theory of material says that the stress and strain relationship is linear. Stress is going to be directly proportional to the strain. E is the elastic modulus. But if we look at the basic definition of Hooke's law, it says that this relationship is valid only to a limit, and that limit is proportional limit or maximum up to the elastic limit. But what happens after the elastic limit? The relationship between the stress and strain exists, but it doesn't remain linear, it becomes non-linear. So in WSM, we assume concrete as well as the steel both act together in an elastic fashion. Like you are seeing this graph here, first graph. So in this, if you look at the relationship, it is linear relationship. So such a curve is called elastic curve. Whereas the limit state method talks of the actual non-linear behavior between the stress and strain for the both material, concrete as well as steel. And such a behavior is bilinear, elastoplastic. So let me tell you the difference between the elastic and plastic. The very basic definition of elasticity of a material is that if we apply a force on it, so material will deform. And if we remove the external force, the material will try to restore its original or natural shape and size from the deformed size. So such a material is elastic. But every material has a limit for the elasticity. So this is the elastic limit for this material. Alright. But if we cross that elastic limit, then what happens? Material will start behaving in an elastoplastic fashion. If we apply a force on a material, the stress is linear to a strain up to elastic limit. But if we cross that limit, then what happens? Material start behaving in an elastoplastic fashion. And what happens in the plastic region? For example, you can see if we have loaded the material from origin to the elastic limit and went into the plastic region, then what will happen? If we release the force, the material will try to restore its position, but we will see that something permanent deformation will remain. So this deformation is residual strain. Alright, so such a material is called elastoplastic material. And we can clearly see the nature of curve is not just linear, but it has become bilinear. And the point that differentiate the elastic region from the plastic region is the yield point. Yield point मतलब क्या होता है? आपने एग्रीकल्चर में सुना होगा, the harvest is also known as the yield. जैसे कि yield of the year कितना हुआ है कि नहीं? So yield is the product, यानी कि अब इसने yield कर गया, means material has now yielded. So this point is yield point. So for your information, I will be discussing these stress strain curve also for concrete as well as steel in the next video very soon. So let us come to the second point. Second point is very easy to understand. It says that stresses in the structural members are considered for normal working loads without considering the conditions existing at the time of failure. और वर्किंग लोड दे दी जाती है और आप उसमें क्या करते हैं? लोड फैक्टर से मल्टीप्लाई करते हैं। लोड फैक्टर जनरली 1.5 होता है और आप डिज़ाइन करते हो WSM में फॉर द फैक्टर्ड लोड, है कि नहीं। सो वी डिज़ाइन इन WSM फॉर द वर्किंग लोड, whereas in case of limit state we know that design is based on ultimate loads at failure. We assume that ultimate load क्या होगा, वर्किंग लोड जो है उसमें हमने पार्शियल सेफ्टी फैक्टर को मल्टीप्लाई करते हैं, और ये फैक्टर्स हमने देखा है लोड कॉम्बिनेशन में from table 18 of IS 456 that. So here many a times different partial safety factors are used for limit state of collapse and limit states of serviceability under different load combinations. और इन सारे लोड कॉम्बिनेशंस को कैलकुलेट करने के बाद जो भी लोड मैक्सिमम आएगी, मीन्स जो भी सबसे वर्स्ट सिचुएशन होगा स्ट्रक्चर के लिए, फॉर दैट वैल्यू ऑफ अल्टीमेट लोड we will be designing in limit state method. Now let us discuss the basic difference in the design criteria of WSM and LSM. So in WSM we have to satisfy two design requirements. The first one related with the load and second one with the material strength. The very first condition is that, just now we have discussed in the second point also, that the load carrying capacity of the structure शुड बी मोर देन दी वर्किंग लोड, क्योंकि वर्किंग लोड में जैसे ही आपने मल्टीप्लाई किया लोड फैक्टर तो आपको फैक्टर्ड लोड मिलता है, और आप फैक्टर्ड लोड को मान रहे हो कि यही मेरी लोड कैरिंग कैपेसिटी है, तो वो ऑफकोर्स वर्किंग लोड से ज़्यादा होगी. सेकेंड पॉइंट इज दैट स्ट्रेसेस इन द मटेरियल वेदर इट बी कॉन्क्रीट और स्टील, इट शुड बी लेस दैन द परमिसिबल स्ट्रेस इन द मटेरियल. What is the value of permissible stress in concrete as well as in steel? F permissible is equal to FCK by factor of safety for concrete, where FCK is the characteristic cube strength of concrete, and FY factor of safety for steel, where Fy is the yield strength of steel. Also the factor of safety for concrete is 1.5 and the factor of safety for steel is 1.15. One thing that come into mind, why factor of safety of concrete is more than the factor of safety of steel? कंक्रीट में फैक्टर ऑफ सेफ्टी क्यों ज़्यादा लेनी पड़ रही है स्टील से? क्योंकि कंक्रीट को क्या करते हैं हम फील्ड में मैन्युफैक्चर करते हैं, तो फील्ड में कई सारे लेबर्स होते हैं, कई सारे पैरामीटर्स वेरी करते हैं, बहुत ज़्यादा यूनिफॉर्मिटी नहीं रह जाती है. दैट्स वाई वी टेक लिटिल मोर फैक्टर ऑफ सेफ्टी इन कंक्रीट, बट इन केस ऑफ स्टील it is manufactured in the company or the industries where every parameter is controlled by the machinery, so we don't need to take much factor of safety in case of steel. Now the only design criteria that we have to satisfy in the limit state of collapse is that load carrying capacity of material when divided by the partial safety factor for that material, it must be greater than the load combinations comprising of all the summation of loads multiplied by corresponding partial safety factor. Design strength in steel as well as the design strength in concrete must be greater than the value which you get after calculating all these load combinations and choosing the maximum value of all the combinations possible. This value must be less than the design load carrying capacity divided by the partial safety factor. Alright. The fourth point says that working stress method doesn't give any idea about margin of safety available for loads to assess the extent of overloading without collapse, because we are designing for the working load, we are not designing for the overloading cases in case of collapse. Whereas in the limit state method it gives us an idea about the excess load which a structure can carry very easily beyond the working load also without getting collapsed, because in LSM we take in our mind a limit state, a hypothetical state before the collapse has occurred, and we design for that acceptable requirements for that state. So it surely gives us an idea about the excess load which the structure can carry. Fifth point says WSM follows a deterministic approach as it assumes that the loads, factor of safety, and permissible stresses are accurately known. So everything is known there. Whereas in LSM, we know that we are following a non-deterministic approach and we adopt probable loads that can come onto the structure before the collapse actually happens. And we also adopt the probable strength of the material that will be available at that time. So it's completely non-deterministic approach and it is based on just experience or observations depending upon the situation. Now the sixth point you can understand if you have understood the first point, that material strengths are not fully utilized in designing the member in WSM. Why? Because we have only utilized the elastic region of the material, whether it be concrete or steel. आपने बस elastic region ही तो use किया ना. Whereas in LSM we not only utilize the elastic region but we also go beyond the elastic limit and reaches up to the plastic region and we utilize the elastoplastic region of the material. That's why the material strengths are fully utilized in designing the member by limit state method. तो आप मटेरियल को फुली यूटिलाइज कर रहे हैं, अंडर यूटिलाइज नहीं कर रहे. इट नेवर मीन्ट दैट वी आर ओवर यूटिलाइजिंग द मटेरियल और एक्सप्लॉइटिंग द कैपेसिटी ऑफ मटेरियल. एक्सप्लॉइट करने का मतलब है कि वी हैव गॉन इवन फार द प्लास्टिक रीजन and that those regions are strain hardening and strain softening which we are not even considering. Now let us discuss few merits and demerits of WSM. The first merit is that WSM is a simple method. Of course it will be, because we are using just the linear behavior of stress and strain. Whereas in LSM, since we use non-linear behavior, of course the mathematical analysis will become complex and the method will be complicated and it will surely involve little more calculations, but it cannot be completely said as demerit. Second point says that since WSM is a simple method, so due to its simplicity it is still being used for design of complex structure such as overhead water tanks, bunkers, silos, water retaining structures, dams, embankment walls, etc. Because in complex structure we can easily apply simple method and get the results. Even if we get uneconomical design or over design, at least we are sure that the design will be stable, na? So that's the goal. But if we apply limit state method in those cases, we are not even sure that even we will reach to the results or not, because the calculation is so complicated, it will become surely. So that's why we prefer limit state method to be applied for simple structures only. But of course this limit state method is slowly evolving for the design of even complex structures with the help of advanced computer softwares. Alright, so till now I was just discussing the limit state method of collapse, but one thing is remaining, limit state of serviceability. See, this serviceability was never talked of in WSM. And what does serviceability requirement says? The control on deflection, जैसे कोई बीम झुक जाती है, and the control on cracking, कितना क्रैक हम अलाउ कर सकते हैं. थोड़ा बहुत क्रैक तो हर जगह होता है, भले ही हमें दिखता नहीं. Those are the minor cracks, invisible cracks. And even if the cracks is visible, we can't say that the structure has failed. There is certain limit on the cracks as well as deflection. Just like the Leaning Tower of Pisa, it's deflected, but that deflection is within the limits, so it's stable. But since the design of WSM is over design, so the serviceability requirement is automatically satisfied because the working stresses are low. क्योंकि इतना ज़्यादा डिज़ाइन हो जाता है, वो डिफ्लेक्ट कहाँ से करेगा, क्रैक कहाँ से आएंगे, ठीक है. सो द मेथड रिजल्ट्स इनटू द बिगर सेक्शन. समझ रहे हैं आप, ओवर डिजाइन में कहाँ से क्रैक आएगी और कहाँ से डिफ्लेक्शन आएंगे. वेयर एज इन द लिमिट स्टेट मेथड द सेक्शंस आर रिक्वायर्ड टू बी चेक्ड फॉर सर्विसिबिलिटी रिक्वायरमेंट्स, एंड दिस इज गिवन इन द IS code. So the next point says that the stress strain relationship for concrete is constant, which is not correct. Yeah, this is true. Whereas in the limited state method, it is a more realistic method. Yes, which takes into account the actual non-linear stress-strain relationship for concrete. Exactly. Fifth point says it results in bigger section size in comparison to that obtained from limit state method. Thus, it gives uneconomical sections. Of course, that's really true. Whereas in limit state method, it results in a smaller section size in comparison to that obtained from working stress method. Thus, it gives economical section. And the last point says it's an old and conservative method which mainly concentrates on safety aspect, and serviceability is automatically satisfied due to over design. Whereas the limit state method is a more rational method which not only takes into account of safety and economy but also fitness of the structure throughout its service life by controlling the serviceability limits. So I think by now you must have understood the exact differences between the both design philosophies. What are the merits and demerits? In the present situation, both the methods are being used depending on the type of structures. But of course, with time, limit state method is being more researched and refined and is coming up with fully equipped modern softwares, technologies in which we can use it for different types of structure. But you should always remember that WSM method can never be neglected. It will be used forever because of its simple design. With this, I would like to end this class, and in next class we will bring you to the new topic of stress-strain relationship of concrete as well as steel. So till that, stay tuned. Thank you.